Welcome to the UGC EPG Pathshala lecture series in computer science. In this series of lectures, we have been looking at software engineering. For today's session, I will be discussing on design with components. Some of the learning objectives of this session include to explain the benefits of software reuse, to discuss several different ways to implement software reuse, and to describe the development of software product lines. For the past few lectures, we have been looking at commonality on the word reuse. First, let us try to understand what this reuse means. Building the components from reusable components. So, whatever that has been built already, if we tend to use it again, we call it as reuse. In most engineering disciplines, systems are designed by composing existing components that have been used in other systems. To achieve better software more quickly and at lower cost, we need to adopt a design process that is based on systematic reuse. We have another software which is called, another field which is called reuse based software engineering, where we can have application system reuse, component reuse and function reuse. When we switch from the problem to the solution, if at all we look at the enterprise has lot of processes involved, and these processes are in turn called from different systems, and these systems will have its own functionalities defined, and these functionality vary between platforms, and this platform has lot of components within it. First, let us try to look at application system reuse. The whole of application system may be reused either by incorporating it without change into another system, that is called commercial off the shelf reuse, or by developing application families. This is widely practiced as software systems and are implemented as application families. So, component off the shelf reuse is becoming increasingly common. If you look at this component reuse, components of an object of an application from subsystems to simple single objects may be reused. So, if you look at this figure, these are grouped, these are components that are grouped together, and any component that is to be reused can be called and can be iteratively processed. Anything can be done, can be easily imported, it's interoperable also. Now, seen as the key to effective and widespread use through component based software engineering. If you want to use the functionality also, we can very well reuse that. Software components that implement a single well defined function may also be reused. This is quite common in some application domains where domain specific libraries of reusable functions have been established. Now that we have looked at a lot on the reuse perspective, let us see what are the benefits of this reuse. Because of reuse, we have increased reliability. Components exercised in working systems, tried and tested under real conditions, that was working fine, that was proved to be a best and had a prototype and a standard, can now be called better be utilized and more reliable. And this has got a reduced process risk, less certainly in development cost. Further, it is effective use of specialists. Reuse components instead of application experts, develop components instead of repeating the same on multiple projects. And further, it has got standards compliance, embed standards in reuse components, maybe in terms of menu format, and we can have accelerated development also, avoid original development and hence speed up production. This may reduce testing time too. What are the basic requirements for design with reuse? It must be possible to find appropriate reusable components. The reuser of the component must be confident that the components will be reliable and will behave as specified. The components must be documented so that they can be understood, and where appropriate it can be modified. Some of the problems that we might come across quite commonly when we tend to reuse the software: increased maintenance cost. If the source code of the components is not available, then other parts modifications must be engineered around the components which are inflexible. If the source code is not available, then if we have directly tried implementing those components into the new software, we may have to re-engineer on the software again and again, so that we may have to build the original code. That might take a lot of maintenance cost. Not invented here syndrome, where some developers resist reuse. So the matter of trust and the question of creativity has gone. And most of the times we lack tool support. Maintaining a component library, effective library for reuse can be built, can be difficult and expensive. Finding and adapting reusable components is also a major problem under reusable category. We have one more category which is called generator based reuse, where program generators involve the reuse of standard patterns and algorithms. So we might use standard patterns and algorithms which are generated again and again, so that it can be used for further purposes. So these are embedded in the generator and parameterized by user commands. A program is then automatically generated. Generator based reuse is possible when domain abstractions and their mapping to executable code can be identified. Any cases where domain abstractions are pretty predominant and their mapping is to be given a clear indication, then we go for generator based reuse. A domain specific language is used to compose and control these abstractions. So if you look at the types of program generator, application generator for business data processing, parser and lexical analyzer generator for language processing, code generator for case tools. Reuse through program generation. We have an application description which helps in program generation, and we create generated program. So for program generator we use application domain knowledge, and for generated program, for all generated program that is getting stored in the database. This we have already seen in the previous session. It is something related to component based development. So we have looked at it as component based software engineering. It is an approach to software development that relies on reuse. Components are more abstract than object classes and can be considered to be a standalone service providers. So there is a repository of components that is available in the market which can compose itself for a specific component based systems. So this component based software engineering provide a service without regard to where the component is executed or its programming language. Components can range in size from simple functions to the entire application systems. Components are also interdependent and are very loosely coupled. Components are encapsulated. If we wanted to look at the component interfaces, components are surely to provide some interfaces. So it defines the services that are provided by the component to the other components. So we have looked at several examples relating to the interfaces that it has created. If at all we have a component called print job, we have two interfaces that we have created. One is to include and one is to the other thing. So this component requires an interface and it can also provide an interface. This picture depicts that every component has an interface and can create an interface, and if it could be provides an interface, this defines the services that are provided by the component to the other components, wherein the other components might use these components by making use of it. Whereas the requires interface defines the services that specifies what type of services must be made available for the component to be executed as specified. In order to execute this particular component, what are the types of services that this system requires, whereas the provides interface is the services that are provided to the external world. So for this printing services component, for a print services component, we have requires interface which gets PDF file or printer interface, and it provides services like print, get queue, remove, transfer, register and unregister. So requires get PDF file to get printer description file for a printer type, and printer int is to transfer commands to a specific printer. These components, as I have already told you, is to the higher level of abstraction and helps in architectural design. This has got different levels of abstraction, starting from functional abstraction, where the components implement a single function such as a mathematical function, or it can even have a casual grouping. The component is a collection of loosely related entities that might be declaration, functions, etc. Or otherwise it can have data abstractions, where the component represents a data abstraction or a class in an object oriented language. It can even be cluster abstractions, where the component has a group of related classes that work together, sometimes called a framework. So this framework, which has a group of related classes, are quite predominant in today's research community. Different level of abstractions also include system abstraction, where the component is an entire self-contained system, provides interface with a so-called application programmer interface. Some of the very well-known component-based software engineering processes include system requirements modified to reflect components that are available, usually involves a prototyping or an incremental development process with components being glued together using a scripting language. So we start from design system architecture, we specify what components required, we search for reusable components, incorporate those discovered components. So this is a simple outline which shows development with reuse. Outline system requirements, search for reusable components, modify requirements according to the discovered components. Any specific requirement which requires slight modification on the existing component, then we may have to redefine on the components. Then we construct an architectural diagram. We go for searching reusable components, specify system components based on the reusable components. One of the problem that we came across is the Ariane rocket problem that we have seen in the previous session. We have another component based software engineering problem also, which says component incompatibilities may mean that cost and schedule savings are less than expected. Finding and understanding components are pretty much difficult. Managing evolution as requirements change in situations where it may be impossible to change the system components. There are situations where it is impossible to change many of the components or many of the situations. At that juncture, some people might force us to change those components or the reuse of the components. That is quite not very much possible. As I have told on the clustering perspective, clustering or grouping together a list of classes becomes a framework. Now that framework are application frameworks, framework are a subsystem design made up of collection of abstracts and concrete classes and interfaces between them. So we have abstractions, we have concrete classes, and we can create interfaces between the abstractions and the concrete classes, which makes it to a framework. So the system is implemented by adding components to fill in parts of the design and by instantiating the abstract classes in the framework. Frameworks are moderately large entities that can be reused. Looking at the different classes of framework, we have system infrastructure framework, we even have middleware integration framework and enterprise application framework. If you look at system infrastructure framework, this supports the development of system infrastructure such as communication, user interface and compilers. These are best developed for these three, particularly for GUI. Say if you consider the system of system integration, where we have multiple operation deployments and we have a OT bus which is connected to the sub, and there is a common integration bus which is capable of supporting all messages and data patterns, and there is a mediation between the OT bus, data bus and messaging, which is directly connected to the integration bus. And any web client can connect to the web server. Further, they can get access to the client, JMS client, and through the mediation they can connect it with the integration bus for various systems. it can be networked. And if we look at middleware integration framework, standards and classes that support component communication and information exchange. As we have already discussed on some of the middleware integrations which are included as components like CORBA, Common Object Broker Architecture, COM, Component Object Model, and DCOM and Java Beans. These Java Beans has got its Bean Development Toolkit. There is other framework which is called Enterprise Application Framework, which is quite favorably discussed in many of the researchers. This Enterprise Application Framework support the development of specific type of applications such as telecommunication and financial systems. If you look at the Enterprise Application Framework, almost all the systems are networked through web services, enterprise application interface, and it provides a trust through a cloud through a network of cloud environment. This not only helps in creating only the framework, it has got strategic and technology architecture, where some of the legacy systems, J2EE applications and .NET environments with enterprise application integration and web services based integration can also be developed. These have been modeled under various architectural levels like business architecture, data architecture, application architecture, where through business architecture we have a legacy, current and future environments with COTS and other future custom applications. We have a data architecture where we have metadata, data structures, data entities, data flow, data storage, enterprise data standards, integration data standards, etc. And we have application architecture, we have J2EE, .NET and future platforms. We have data exchange architecture which has got XML based web services and other legacy data exchange EDI technologies. So these have been entertained under various architecture starting from the business architecture level to the data architecture level, and there have been application and data exchange architecture levels also. Not only that, we have in this architecture we have got something like legacy systems, we have got custom applications, we have got innovative products, we have got commercial off the shelf platforms that has been developed, and this framework has been layered into data exchange architecture, application architecture, data architecture and business architecture. And this also provides a security best practices where traditional multi-layered security and emerging end-to-end message level security has been completely used, and this uses WS security standards also. Further to that, this can also be incorporated for innovation, product and service oriented solutions. As an extension to this framework, we will have a framework that can be generic and are extended to create more specific applications or subsystems. So extending the framework involves adding concrete classes. Although it has got abstractions, concrete classes integrated together, interfaced together within a group of clusters. Now that we can add some more concrete classes that inherit operations from abstract classes in the framework. Adding methods that are called in response to events that can be recognized by the framework, which are nothing but callbacks. We will talk something on the model view controller, where it has got a system infrastructure framework for a GUI design. This allows multiple presentations of an object and separate interactions with these presentations. MVC framework involves instantiation of number of design patterns. So this model view controller has got requests from the user directly to the controller, where it has got its application logic, process the user request and get appropriate data, then output to the design view. And it has got a model where all the data related items are getting stored. So database related, not necessary database, data can be XML, even text files getting stored at this location. and there is another set of data which can be viewed by the external world, your website design, HTML files, no images, CSS, etc. Here only HTML layouts, which is given as a response back to the user. So this is a simple MVC that we could construct. And when we look at the commercial off-the-shelf product reuse, systems are usually complete application systems that offer application programming interface. Building large systems by integrating COTS systems is now a viable deployment strategy for some types of systems such as e-commerce based systems. So if you look at the component reusability, this component reusability should reflect stable domain abstractions, some of the fundamental concepts in the application domain that change slowly, for example bank accounts, students of the university, etc. should hide state representations, should be as independent as possible, should publish exceptions through the component interface. That means different applications will have different requirements for exception handling. So let applications handle them rather than trying to handle them as a component. As an enhancement to reusability, we have name generalization, we have operation generalization. Name generalization means names in a component may be modified so that they are not a direct reflection of specific application entity. Whereas operation generalization mean operations may be added to provide extra functionality, and application specific operations may also be removed. It can in turn have exception generalizations also. In case of exceptional handling, application specific exceptions are removed and exception management added to increase the robustness of the component. Component certification, component is certified as reusable if the initial component we perform a name generalization, then perform an operational generalization, then have exception generalization, then have a component certification. Further, the component is made completely reusable. In short, in this particular session, I have talked more on reusability perspective, where we started saying about how an application can be reused, or a component reuse, or a function can also be reused. Then we have looked at the benefits of reuse. Further, we have described on the independent frameworks which talked more about group of classes, and the types of framework that we have seen were system integration framework, middleware integration framework, and enterprise application framework. And I have made a point on model view controller, and finally I gave an introduction to reliability enhancement, how the components can be reused through way of passing through different generalizations. Thank you.